Yes, I'm Dr. Harsh Verma and I'm from NIT Jalandhar. Today I'm here to deliver a talk on language constructs, which is a topic of object-oriented programming. These are the outline of my today's lecture. Firstly, I'll be introducing you to the object-oriented programming. Then we'll be discussing something related to variables, data types, and different types of operators. For example, arithmetic operators, relational operators, logical operators. Then we'll discuss regarding control structures. In control structures, we'll discuss if else, nested if, else, while loop, for loop, and do while loop. Then we'll also discuss switch, break, and continue. In the last, we'll discuss input output streams and standard input output devices. So before introducing object-oriented programming, we can understand that it is an unencapsulated state where an object has the property of inheritance. Whereas if you describe object in class, object is nothing but an entity that has a unique identity and that can encapsulate state, and this state can be accessed in a controlled way from outside with the help of procedures or methods. Then the access to this state of the object can be had with the help of procedures that can directly access the internal state. And if you think of a class, then class is a specification of object in an incremental way. By inheriting, we can have another class from another class. Whereby inheriting means we can have properties of the base class into the derived class, and specifying how its instances or objects differ from the objects from the derived classes, inherited classes. Now, I'll describe what is a variable first. In any program, we must have seen we have either data or instructions, and data and instructions are there to manipulate that data, and instructions these are used to manipulate the data. Now, data has to be stored somewhere. We need some space in the random access memory. Now, in C++ program, a variable is the entity that holds the data. For example, we have to declare some variable of data type of the variable before using it, what kind of values we want to store into the variable, what should be the size of the values we wish to store, and what is the life of the variable. All those things need to be declared to be known to the compiler, so that a variable, the name suggests, as the name suggests, is a varying entity, and depending on the actual data it holds. Without variables, it would be impossible to store data. Now, let's see the example here. Firstly, before going to the example, we'll describe the characteristics of the variable. The variable has generally the following characteristics. Any variable you declare in any program, it will have a symbolic name and an associated physical memory space, some portion in RAM. Then its data type, what kind of values we want to store, that will be its data type, a value that depends on the data type. Then the scope and the lifetime, which I told earlier. So these are all scope of the variable means whether the value of the variable will be alive in the loop, or whether they will diminish after how many instructions and during the program, or their life is up to in the function itself, or all these things come under scope. What is the scope of the variable? Whether the variables will be passed to the functions or not, and the values will remain or not. Now, last but not the least is the lifetime of the variable. So these are the general characteristics of a variable. Next is data type. These are the basic data types in object-oriented programming. First thing is, what is data type? It generally specifies the kind of values that can be assumed by a variable of that type. Now, next thing is the range of the values that can be assumed by a variable of that type, and the amount of memory needed by a variable uh, to be stored a value of that type. Now, 5 basic data types in object programming. One is character type, another is integer type, float type, double type, and boolean type. If you declare a variable of character type, then character type data is used to represent the store manipulate character type data values. And if you declare it as integer type, now depending upon the compiler, the size of the variable will be variable will be there. The integer data type is used to represent, store, manipulate, signed whole numbers. For example, the range is given here. If you declare declare a variable of integer type, the values it can have starts from -21474 83648 to 21474 83647. So this is the range which is specified. You can store range of values which is given. For example, if you declare the variable of float type, then also the range is given 3.4 into 10 to the minus 38 to 3.4 into 10 to the 38. And if you declare the variable of double precision floating point data type, then the range is also specified as 1.7 into 10 to the power minus 308 into 1.7 into 10 to the power 308. Now, if you declare a variable of Boolean type, they are used to represent the Boolean values true or false. So we can either declare a variable of any of these 5 basic data types in object programming. Now, a variable declaration is an action basically by which a variable is introduced to the program. So by declaring the variable, we understand that what kind of values it will have during the execution of the program. And all variables in C++ program must be declared. If you forget to do so, the compiler will report a syntax error. And if you don't declare and use a variable straight away, then the compiler will show error. The syntax, how do we write, how we declare variable, that syntax is given, data type and then variable names. You have to specify data type as integer, Boolean, character, or whatever it is data type. Then the variable names, you can give the names x1, x2 or ABC, whatever you like to have. There are naming rules for naming a variable. Then a semicolon which signifies the end of the declaration. So every statement is terminated by semicolon. So if you made a declaration, so that has to be that also has to be ended somewhere. Now these are the valid examples. CH has been declared here as character type, B as a Boolean type, I as integer type, and F as float type. And finally D has been declared as a double type. And after each declaration, a semicolon has been put to mark the end of the declaration. Now these are further more examples. CH1 and CH2 has been declared as character type, and B1 and B2 has been declared as Boolean type, XYZ. So we have already discussed what kind of values they can have and the range of values. If we store larger number than what has been declared, so there will be overflow error. Like XYZ has been declared as integer type, the maximum value which we have talked about. If the value is try to store more than that, so that will give you an error. Next is float, degree Celsius, degree Fahrenheit, degree Kelvin. So and last is 2 variables, numerator and denominator are declared as double type. So these are some examples of declaring variables. Now what are operators? Operators are symbols representing the operations that can be performed on constants and variables. There are basically 4 operations available in OOPS. One is assignment operator, then we have arithmetic operation, relational operation, and logical operation. Now the assignment operator is denoted by equal sign, that is equal to. it is used to assign a value to a variable. The syntax has been given you in the left hand side there is a variable name, and the right hand side there is an expression. Now this is the valid way of using an assignment statement. Other way around it is not possible. Like if you say that on the left hand side there is an expression, on the right hand side variable name is there, then it will give you an error. So the variable can have a valid identifier. Variable name should be valid identifier in C++, and while expression can be constant, variable, or valid expression. So what will happen, the expression which is on the right side will be evaluated. For example, x plus y minus 4, some valid expression, anything can be there. So that value will be evaluated, and where value will be assigned to the variable name which is on the left side of the assignment operator. Now these are some examples of assignment operation. Just see that ch1 has been assigned as a z character, then ch2 has been assigned a value which is marked to ch1 and x equal to 5, and there is another assignment which is called y is equal to x. Now if in some cases we assign a value whose data type is different from the data type of the receiving variable, the data type of the value will be converted to the data type of the variable. So either they have to be demoted or promoted. Now on the left hand side you're using assignment operator. Left hand side is some integer, and right hand side you are assigning a value which is of float type. So float has to be converted into float value cannot be assigned to an integer type variable. So float has to be converted into integer first, and that value will be assigned to integer type variable that has to be converted. If the type of the, for example, ch2 and ch1, we have made an example here that ch2 has been if both of them they are character type, so then there is no problem. If ch2 is character type and ch1 is integer type, then ch1 type has to be converted into character, and then that value will be assigned to ch2. And if you look at the arithmetic operators, plus, minus, asterisk, slash, percentage, double plus, and double minus, the description is plus is used for addition of two operands, and minus is used for subtraction, difference of two operands, and then multiplication, so multiplying two operands, slash we use for dividing to find the quotient, two operands, and percentage that returns the remainder. It is a modulus operator. We use it for calculating the remainder. Then plus is an increment, and it returns the value of the operand plus 1, and minus which is called double minus is decrement operator, returns the value of the operand minus 1. So these are the various arithmetic operators which we use in object-oriented programming. And there are some important notes which we should remember when we use these operators. Like earlier I told, assigning a variable to a constant is a syntax error. For example, we should have we have a number here in the left hand side, and right hand side there is a variable name. So which is an error? It should be other way around. X equals to 1, 2, 3, 4, 5. Then there will not be a syntactical error. But in this case, you will get a syntax error. 1, 2, 3, 4, 5 cannot be equal to x. So our variables are to be on the left hand side, and has to be only one variable on the left hand side, and right hand side there can be expression, can be a constant, can be a expression. So another example you see, assigning the value to a variable of the same name is syntactically correct, but practically useless and doesn't make any sense. Let's say a has a value 1, 2, 3, 4, 5, and again you are assigning the same value, so that is useless, but it will not give you error, syntax error, because it is a valid syntax. So but there is no use assigning the same value which earlier it has. It is usual in programming to assign a value of an expression to a variable, wherein the old value of the variable is also used in the expression. For example, if you see we have assigned 50 to variable a, and then we are incrementing the value of a by 1 and assigning to a. So what 50 is assigned, then what is happening? The new value of final value of a will be 51, which is obtained after adding 1 to 50 on the right hand side. So right hand side is an expression which is evaluated, and the value is assigned to the left hand operator on operand on the left hand side. Now these are some relational or comparison operators: double, equal to, not equal to, greater than, less than, greater than, equal to, or less than, equal to. So these relation operators we do use in object-oriented programming as well. And if you see that these operators can be performed on all basic types, the result of these relation operators is either 0 or 1. If a 0 comes out, then it means the relation is false, otherwise it is true. Now all relation and comparison operators are binary operators. It is important to remember that the test for equality uses two equal symbols. Forgetting one of the equal sign is a very common logical error. And if you see, these are the logical operators. Not sign of explanation is for not, and double ampersand sign if we put for use for AND operator, and double bar is for OR operator. The logical operators are normally used in conjunction with the relational operators to test the multiple conditions. Now we can use in conjunction. Already we described some relational operators, these are the logical operators, and we can use in combination for multiple conditions. Now logical NOT is a unary operator, and it is used with only one operand on to the right, and remaining of the operands can be binary operators. The logical NOT operation is performed before logical AND or before logical OR. Now this is very important. If you look at the usage of the operators, many operators we talked about arithmetic operators, we talked about relational operators, we talked about logical operators, and which operator will have better choice for execution, first choice. So precedence is shown here, left parenthesis and right parenthesis, and postfix plus plus and postfix minus minus, they have the highest precedence, and their associativity is left to right. How do we execute it? We have to execute the expression within the parenthesis from left to right. So this is the precedence of operators. And the next precedence is for not, prefix plus plus, prefix minus minus, ampersand sign, and size of, and their associativity is from right to left. This precedence and associativity we have already, if you see the arithmetic, some expression is given to us within parentheses, where we use double parentheses, then plus, minus, multiplication, all division, all other things. So there is a rule for which is to be executed, which is to be calculated first, and how do we do that. So these are the standard things. Typecasting is there. If you convert from one data type to another, like say a float to data type to integer data type, so typecasting has to be performed. So their typecasting has the associativity is right to left. Then we have more precedence of multiplication, division, and a modulus, and their associativity is left to right, and plus and minus, then their associativity is also left to right. Less than equal to, greater than equal to, their associativity is also left to right, but has lower precedence than plus and minus. And double equal to, not equal to has lower precedence than less than equal to, and their associativity is also left to right. Then we have double ampersand sign, their associativity is also left to right. Logical OR is there, then associativity is also left to right. Then in the last we have assignment, multiply equal to, divide equal to, modulus equal to, plus equal to, minus equal to. So the associativity is also right to left. Now a very important thing we generally talk about whenever we have to write a program, we must go for a flowchart. Flowchart is generally a pictorial representation of the logical sequence of instructions which are to be executed in order to solve a particular problem. So basically, they are the graphical representation of an algorithm. Now they are drawn using some special symbols connected by arrows, also called flow lines. And there is a rectangle symbol, which means we also call it action symbol. Action symbol indicates any type of action, and there is a oval symbol indicates the beginning or end of the program or section of the code. Now there is a single entry and single exit control structures, and they connect exit point of one control structure to entry point of the next control structure, and it makes program easy to build. So generally, when we do coding, we draw a flow chart first. So it helps us coding the program easy. Now there could be errors in the control structures. There could be syntax errors, there could be logical errors, and if you find syntax errors they are caught by the compiler. Whenever you write program, you compile it, and the compiler then signifies we cannot execute the program unless all the syntax errors are removed. So then even if there is no syntax error, there could be some logical errors, and there are some logical errors which are fatal and which are non-fatal, and they have their effect at the execution time. Non-fatal errors, program runs but they has incorrect output. In fatal, program exits prematurely. Sometimes it comes out of the loop, comes out of the program without giving any output. So so they have the effect at the execution time in logical errors, if you talk about logical errors. So if you want correct output, there should not be any syntax or logic errors. If we look at the if selection structure, it is used to choose among alternative courses of action. For example, if you look at the pseudocode, if student's grade is greater than or equal to 60, then we have to print passed. Now the condition is mentioned here, that is student grade should be greater than 60, greater than or equal to 60, and the condition is true, then we are instructing the computer to print passed. Otherwise, it will simply go to the next statement without printing the passed. Now print statement is executed and the program goes to the next line. If the statement is true, then print statement is executed, then next statement. If the condition is false, then print statement will be ignored. So and then it goes to the next statement. So C ignores the white space characters in that case. Now this is the flow chart. If you look at the flow chart, grade is greater than 60 and if it is true, then we will print a message or cout. We print the message and we go to the backslash new line character is there, passed, and is coming out. And if grade is not greater than 60, if let's say grade is 50, simply we are coming out and executing whatsoever instruction is coming next. So this is the control structure, usage of control structure if. Now you see the syntax, if expression 1, and then there is a C++ block of statements, and if expression is true, if you generalize it, it look like the flowchart look like this. If the expression is true, execute the sequence of statements given in the block. Otherwise, if the expression is false, it straightaway come out. So for example, expression could be grade is greater than equal to 60, and if you are printing grade is greater than 60, it's fine. Then message will come as passed, and if the grade variable has less value than 60, so it simply exit this statement and comes to execute the next statement to it, whatsoever will be the next statement. Now look at another statement, if else statement. This is a different control structure. We have now option. If the expression 1, there is a syntax given, if expression 1, then we have block 1 of statements which is to be executed, else block 2 is to be executed. So one of the block has to be executed, either 1 or 2. So the expression 1 is true. So if you look at the flow chart, block 1 of instructions gets executed, and if it is false, so block 2 of instructions gets executed. Now what is happening, you see the example, and if grade is greater than equal to 60, so if it is, this expression is true, so we print passed. We else if the grade is less than 60, less than 60, then we print failed. Now if you see the nested if structure, we have look at the syntax, we have multiple conditions here, whereby all have with the else statement, where if expression 1 is true, then block 1, else if expression 1 is not correct, if then another expression, multiple conditions. So if expression 2 is true, do block 2, else if that is also not true, expression 3, and if that is also not true, if that is true, expression 3 is true, execute block 3. If that is also not true, or whatsoever will be their situation, we have to execute block 4. So see the example, nicely given the example. If grade is greater than 90, so your GPA is A, and if else if, it means if the grade value is greater than 80, some let's say 85, so the second one will be executed. Else if grade is greater than 80, that is 85 is greater than 80, so the message will be printed as your GPA is B, and it comes out. And if that is not the case, if the case is like grade value is 75, then the third case gets executed, and if it is 65, fourth will be executed. And for example, if the grade value is less than even 60, so last case your GPA is F will be listed, and you will cry. That message also will come. So this is for all situations. It depends on the which statement will be executed. We are conveying to the machine, our computer, like depending on the value of the grade. If the value is greater than 90, what we have to do, print. Grade value is greater than 80, what we have to print, and we can solve many problems. Now this is a conditional operator. We use question mark as conditional operator. Before question mark there is a relation, and if that relation is true, then the statement true statement, and the relation is false, then we can represent your if statement with the help of this conditional operator. Example is shown here at the end, that is total. If total is less than equal to 3850.0, if this expression or relation is true, so the first portion will be executed, that is total multiplied equal to 1.10, and if that is false, so the second portion will be executed, that is total multiplied by 1.05. So if the relation is true, the whatever you write on the left, on the column left, that will be executed, otherwise right side of the column statement will be executed. Now we have control structures. While loop we use for control structures for repetition. Let's say some instruction we want that they should be executed number of times, and that repetition structure allows programmer to specify that an action is to be repeated while some condition remains true. Now with the help of the condition, we control the loop. We check the condition first, while loop, and before execution, whereas in do while we do vice versa. We execute the instructions and then we check the condition in case of do while. Possible endless loop if the condition is always true. So if the condition remains always true in the while statement, so probably the loop will never end, the program will always be in a loop. So that will be the endless loop. Now let us look at the example of while loop. While first if we look at the syntax, while expression 1 is given, then some block of instructions, C++ block of instructions is given. Now what is happening, we check the expression first, and if the expression is true, and then we execute those instructions, go back again and again check the expression 1, and if again expression 1 is true, it keeps giving us true value, that loop will never end. The loop will break only when the expression is false and it comes and executes the next instruction. So this is the while loop. So we can make the computer execute some statements number of times which we want, as much we want. For example, we have an example whereby we have declared a variable num equals to 0, and then what we are doing, we are using a while loop whereby num value is less than 100, less than equal to 100. So what we are printing? We are printing 0 into 0. So first time 0 will be printed, and next time num value we are incrementing by 2 now. Num value will be 2 now, and 2 is less than 100. Yes, again expression is again true, while expression. Then